This is Geometry, Unit 6. We're on day number 1. We're going to find and use our slopes of our lines. So the first thing we want to talk about is what is a slope. And a slope is a steepness of a line. In story problems, it's often considered a rate of change. What is the rate of change? That is, what is the slope of the data? On a graph, we talk about slope as rise over run. You count up how much you come up and you count how much you go over for rise over run. The rising part are your y values, that's the up and down, and the running part are your x values, that moves right or left. So in terms of our coordinates, you would subtract your y values and you would subtract your x values. The y values have to be on top. That's a common mistake. When we look at a particular line and we watch it increase to the right, that is always going to be a positive slope because the y value is going to be positive going up and the x value is going to be positive going to the right. You could consider the y value being negative going down, but then the x value is negative going left. So two negatives make a positive. That has to be a positive slope. Negative slope always falls to the right. You might consider your y value being negative, but your x value being positive. So that falls to the right. Zero slope, I'm not quite sure what this is implied. Zero slope would be flat like a floor. And if we were thinking about what a fraction would look like, this would have a numerator as 0. Numerator equaling 0 will give you a 0 slope. Then we have an undefined slope. Undefined slope is the wall. You can't ski down an undefined slope. You might be able to jump off of it, but you can't ski down it. So that is when the denominator equals 0. So those are our facts. Facts about slope. The common mistake is putting x's over the y's, or where you work with x and y's together on top and x's and y's from the same point on bottom. That doesn't work either. You have to use y2 minus y1 over x2 minus x1. When we have a grid, it's going to be a lot easier, and I would encourage you to do it. Just count. But you got to watch your scale. Notice how this is the y's have a scale of 2. So we're going up 2, 4, 6, 8 and a half. So that would be to the 9. So up 2, up 2, up 2, up 2, and then up 1. So we went up 9. Put a 9 there on the side. And then sideways, if you notice the scale is going by ones, that moves over 1, 2, 3, 4. But it's to the left, so it's going to be negative 4. So our slope is going to be rise over run. Now notice this wouldn't matter if we went from A to B. If we went from A to B, we would have gone down 9, so negative 9, but then we would have gone positive 4 to get to the B. So that would still be a fraction. That is negative. A lot of times we put the negative sign right in front of the fraction bar, but I wrote this a little too close. I already put the negative on the 4. Okay, but if it's sitting in front of the fraction bar, this just doesn't matter which part of the fraction is negative. It's just one part would be negative. Let's try this next one. When we connect the a and the b, notice that the height, the y value change is 0. So our slope is m. Remember, that's going to be rise over run. And we're rising up nothing, but we're running over an amount. It really doesn't matter what amount we run over, because if the numerator is 0, then the slope is 0. As long as the denominator is not 0, if the top is 0, we get 0. But here on our next set of examples, we don't have a grid. Okay, theoretically, you could put it on graph paper, and you could count your way through it. That would be one way to handle it. Here is our slope formula. Change in y, so that's y2 minus y1 over the change in x, x2 minus x1. So we want to label our points, x1, y1, x2, y2. If you label your points, that will help you stay organized. So y2 minus y1 over x2 minus x1. Now look at the x1. It is a negative. The common mistake is for people to say 1, oh, negative 7, say minus 7. And they don't know if they should keep the negative or whatnot. But the formula is minus, or negative, subtract the negative 7. When you have a negative followed by a negative, it's kind of like walking backwards but walking backwards. And when you walk backwards but backwards, you actually go forwards. So if you subtract the negative, you're actually going forwards. This is 1 plus 7, which is 8. So we get 4 over 8, which is 1 over 2. That's a positive slope of 1 over 2. In our next example, label your points x1, y1, x2, y2. It keeps you organized. Then you have your formula, y2 minus y1 over x2 minus x1. So your y2 would be the 9. Your y1 would be the 3. x2 would be the 4. x1 would be the 4. Now, a lot of people say, how do you know which one is x1 or x2? How do you know which point to put the 1s on and which points to put the 2s on? It wouldn't matter. It would be okay to say 3 minus 9 and 4 minus 4. If you went the other direction, 3 minus 9 and 4 minus 4, you would get the same result. In this case, we're going to get 6 over 0, which is undefined. And we abbreviate that UND, undefined. So this should be something you've seen before, you've done before. You should feel a little confident working with this. Now on your SATs, if it's the PSAT, typically for 10th grade or 9th grade, and the normal SAT, you often have graph interpret. So here, 2 people go outside to exercise. Find the rate, or rate of change, at which each person exercised in miles per hour. Notice, or miles per minute. notice what they're telling us here. They're showing us how to set up our ratio, our fraction. They're telling us to put the miles, because that comes first, miles per, tells us that it's going to be a fraction. Per minute tells us to put the minutes on bottom and miles on top. So for person A traveled 4 miles in 20 minutes. So 4 miles in 20 minutes, we can reduce that. 4 goes into 4 one time, so you're going at a rate of 1 mile. Divide this guy by 4 in 5 minutes. And that's a pretty quick rate if you're running, if you're exercising. And then we have person B. Person B, using our chart over here, they have traveled 2 miles in 40 minutes. Two miles, 40 minutes, that would reduce. So 2 goes into 2, 1 minute. And 2 goes into 40, 20 times. So we're at 1 mile in 20 minutes. What is the relationship between the rates and the slopes of these segments? Well, the faster the person, the more distance they're covering in less time. The faster, the more steep the line. The slower, the less steep, or closer to a 0 slope. You look at person B, and the pencil is closer to being flat at a 0 slope. Person A is further away from being flat. Right? It's steeper. It's faster. What relationship between these rates, or what is the relationship between these rates and the slopes of the segments? Okay, I'm going to change my steeper because I think we're going to use that wording down here at the bottom. The rate 1/5 is larger than 1/20. You can think about it like a quiz score. If you got 1 wrong out of 5, or if you got 1 wrong out of 20, well, let's say 1 right. That would be 0.2, and this would be much lower. The rate 1/5 is larger than 1/20. So 1/5 is a greater slope. Then at the bottom, what does the slope or the steepness of the segment tells you? The steeper the slope, I think you'll like this one better. The steeper the slope, the faster the rate. All right, now we get into the good stuff. Here are a little bit more of the calculations. 2 lines are parallel. if and only if they're slopes. What do we suspect from parallel slopes? What would be true? What do you suspect? They would be the same. The slopes are the same. Two lines are perpendicular. Let's give this a try. Two lines are perpendicular. So if I have a point and a slope of rise up 3 over 1, rise up 3 over 1, down 3, backwards 1, I have this line with a slope of rise over run, 3 over 1. If I have this other point and we want to be perpendicular to this line, the common mistake is to flip this fraction over and say that the perpendicular slope is going to be 1 over 3. Up 1 over 1, 2, 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. And you can see when we draw that line in, that is not perpendicular. That's not a 90-degree angle. So 1/3 didn't work. But if we do rise up 1, go backwards 3, rise up 1, go backwards 3, we get this slope that is negative 1/3, and there you have your right angle. So opposite reciprocals, you need to flip the fraction over and change the sign. Opposite reciprocals. Some people call it negative reciprocals. Both refer to the same thing. So we're going to look at these lines. This line number 1 is made up of these 2 points. Line number 2 is made up of those 2 points. So we're going to put x1, y1, x2, y2. We're going to label our points. We're going to find out the slope of line 1, which is going to be 4 minus 0 and 7 minus 1. That's 4 over 6. That can be reduced. What number goes into 4 and into 6? So I'm dividing both of those numbers by 2. So I get 2 over 3. That by itself doesn't mean anything. You're not parallel when you just have one set of data. You need another set of data. So now we're going to take y2 minus y1 and x2 minus x1. That gives us 9 over negative 6. 3 goes into both of those numbers. 3 goes into 9 3 times. 3 goes into 6 2 times. I put my negative sign in front of the fraction, implying that it can either be on top or on bottom. It doesn't really matter. It's still considered a negative fraction. These are opposite reciprocals. because their fraction is flipped over and the sign is opposite, is different. So line 1 is perpendicular to line 2 because we have opposite reciprocal slopes. That would be a little rare because it has to be so precise. It has to be the fraction upside down with the opposite sign. Let's try the next question, where we label those points x1, y1, x2, y2. We're calling this line 1. So we have -2 minus 1 and -7 minus a -3. Well, you got to be careful when you're minusing a negative, because it's actually -7 plus 3. So this becomes -3 over -4. If both the top and the bottom are considered negative, it's going to have a positive slope. You can see that here. If I take a point and I do -3, go down 3, and I go -4, go to the left 4, connect those together, I am increasing to the right. That's a positive slope. Line number 2 is 4 minus -1, so you got to write 4 minus. You got to use parentheses. And 8 minus 2. So 4 plus 1 is what this calculation would be. When you're minus, that means you're going backwards, kind of. So we're going to go backwards a -1. But in -1, you have to walk backwards. So you're actually still walking forward. If you go backwards to go backwards, you're actually going forwards. Sounds crazy. 5 over 6. Look at these two slopes. Are they opposite reciprocals? They are neither. Okay, they are not parallel, they're not the same slopes, and they're definitely not opposite reciprocal slopes. Then our last one. You go ahead, pause the video, and you calculate out this one. And then come back and we'll walk you through it. So we label our first point x1, y1, and our second point x2, y2. It doesn't matter which is which, but the 2's have to be together, the x and y have to be together, the 1's have to be together, the x and y has to be together. So remember, our formula is y2 minus y1 over x2 minus x1. 5 minus 4 over 10 minus 7 gives us 1 over 3. Line number 2 would be 5 minus 3 and 8 minus 2. That gives us 2 over 6. So when we look at it like this, they look different. But this fraction might be able to be reduced. What number can go into 2 and also into 6? So we're going to divide out a 2, take a factor out of it, and that leaves us with 1/3. So these are the same slope. So same slope is going to be parallel. Parallel lines if you have the same slope.